you probably have a 2,000-degree hazard hiding inside your walls right now.
Yeah, right above your head, honestly.
Exactly. Wrapped in this rigid sponge that is literally, well, slowly tearing itself apart. And the wild part is you probably walk past it every single day without giving it a second thought.
Most people do, yeah.
Right. So today we are looking at your chimney. We've got a whole stack of detailed resources and field reports from select chimney services out of Portland, Maine. And our mission for you on this deep dive is to uncover the surprisingly complex science happening right above your head.
It really is a battleground up there.
It is. We're looking at how extreme weather and fire interact to threaten the structural envelope of your home. So this is basically a shortcut to understanding a hidden battle that can, honestly, save you thousands of dollars. Okay, let's unpack this, because to understand the fire hazard inside the house, we first have to understand the microscopic warfare happening on the outside.
Right, the outside is where it all starts.
Because we look at brick and mortar and we just see the fortress, right? But the reality is fundamentally different.
It really is. I mean, the biggest misconception we have as homeowners is looking at masonry and assuming it's this solid, impenetrable block of earth.
Right, like a rock.
Exactly. But at a microscopic level, bricks and the mortar holding them together are, they're inherently porous. They literally act like rigid sponges.
Rigid sponges.
Yeah, so every time it rains, or, every time heavy fog rolls in or snow melts on the roofline, that masonry is actively absorbing the environmental moisture around it.
Okay, a rigid sponge. I mean, I get the physics of that, but if you're building a structure meant to live outdoors and, vent a massive fire, why use a material that constantly drinks in water? Wouldn't you want something completely impermeable?
Well, what's fascinating here is that the porosity is actually intentional to a degree anyway.
Wait, really?
Yeah, masonry needs to be able to breathe. When you have intense heat on the inside of a structure and freezing cold on the outside, moisture vapor naturally develops.
Oh, like condensation.
Exactly. If the material were completely impermeable, that vapor would be trapped within the wall cavity forever. So the porous nature actually allows the structure to dry out over time.
Okay, I see.
The problem isn't the absorption itself. The problem is what happens to that absorbed water when the temperature suddenly drops.
Ah, right. The freeze-thaw cycle.
Exactly. We all know water expands when it freezes, but the actual mechanics of it are just brutal on masonry. When water infiltrates those microscopic pores and the temperature drops below freezing, the water molecules form a crystalline structure, ice.
Right.
And that physical transformation causes the water to expand its volume by approximately 9%.
Okay, 9%. I mean, 9% doesn't sound like a lot until you put it in a confined space. It's like leaving a full glass bottle of water in the freezer.
Oh, that's a great way to look at it.
Yeah, because that 9% expansion has to go somewhere. And because the glass is rigid, it just shatters. The pressure is too immense.
That internal pressure is staggering. The ice has nowhere to go, so it pushes outward against the internal walls of the brick. And in the masonry industry, this mechanical failure is called spalling.
Spalling?
Yeah, the expanding ice literally shears off the outer face of the brick.
Wow. But if that's happening way up on the roof, how does a homeowner actually spot it? Like, are we looking for entire bricks tumbling down into the gutters?
No, it starts much more subtly than that. You might be walking around your property and notice just a small accumulation of red dust.
Just dust.
Yeah, or maybe some coarse sand or tiny flakes of clay on the roofline, or maybe washed down to the base of the chimney.
Okay.
That debris is the very first physical evidence that your rigid sponge is losing the battle against the ice.
Got it. And the sources from Select Chimney actually mention another warning sign alongside the spalling, something called efflorescence.
Aha, yes, efflorescence. That is a chemical indicator that your masonry is fully saturated. You'll see these white, chalky, powdery stains appearing on the exterior brickwork.
The white bloom on the brick. Exactly.
What's the actual chemistry causing that, though?
It's dissolved minerals, mostly. The mortar holding the bricks together contains natural mineral salts, primarily calcium hydroxide.
Okay.
So when moisture isn't just sitting on the surface, but is actively moving completely through the masonry wall, that water dissolves those internal salts.
Oh, so it's cooling the salts out.
Right. The water travels outward toward the surface of the brick, and when it finally reaches the exterior and evaporates into the air, it leaves those white mineral deposits behind. So if you see that white staining, you know definitively that water is traveling entirely through the structure.
That makes a lot of sense. But I do want to push back on the timeline here a little bit.
Sure.
Because if a climate like coastal Maine with all its snow and ice breaks masonry down, why is the destruction so rapid?
Yep.
Like, if it freezes in November and stays frozen until March, isn't the expansion just happening once?
Well, see, the climate itself is the ultimate torture test, specifically because it doesn't just stay
Right,
frozen.
doesn't. No. Coastal Maine's environment is defined by its microclimates and this constant temperature oscillation. From late fall through early spring, the temperature doesn't just drop and stay there. It fluctuates above and below the freezing point, sometimes daily.
Oh, wow. So it's the repetition?
Yes, it is a relentless mechanical expansion and contraction cycle. The water freezes, expands by 9%, and fractures the microscopic pores of the brick.
Right.
Then it thaws the next day, leaving behind a slightly larger microscopic void.
Oh, I see where this is going.
Yeah, the next rainstorm fills that new, larger void with even more water. Then the temperature drops again, and that larger volume of water expands another 9%.
Man, that's brutal.
Over several seasons, this ratcheting effect completely disintegrates the mortar joints holding the whole structure together.
So the outside of the structure is basically being wedged apart by microscopic ice, creating a path for water to breach the roofing envelope. But if the mortar is crumbling and water is pushing its way through the brick, what happens when that freezing moisture meets the actual fire on the inside?
Well, that's where the hazard shifts from structural to highly combustible.
Okay.
While the outside is dealing with ice, the inside is dealing with the complex chemistry of burning wood. Because when you burn a log, it doesn't just turn to ash.
Right.
The heat causes the wood to undergo pyrolysis, which releases unburned volatile gases, hydrocarbons, moisture, and tar fog.
Basically the smoke.
Exactly. What we see is smoke. Now, the fire in the firebox is extremely hot, but the chimney walls, especially further up the flue toward the roof, are relatively cool.
Okay, so you have a temperature clash inside too.
Right. As those hot, volatile gases travel up, they hit the cold masonry and condense, just like steam condensing on a cold bathroom mirror. And this leaves behind a dark, highly flammable residue called creosote.
And according to the data from Select Chimney Services, this creosote isn't just a static layer of soot, right? It chemically transforms over time under continuous heat.
Yes, it develops in 3 distinct stages. Stage 1 is the flaky, velvet-like soot most people picture. It contains a lot of unburned carbon, but it's relatively dry and honestly brushes away easily with a standard chimney sweep.
So you brush it away and you're fine. But if someone, say, skips their annual maintenance, how does that fluffy soot become the 2,000-degree hazard we talked about earlier?
Continuous heat exposure.
Yeah.
When you light subsequent fires, the heat traveling up the chimney bakes that stage 1 soot. It drives out the remaining moisture, causing the molecules to polymerize.
Polymerize, okay.
Yeah, it transforms into stage 2 creosote, which has a thick, tar-like consistency. It's incredibly sticky. A standard wire brush will just glide right over it. Professionals actually have to use specialized rotary chains to physically grind it away from the flue walls.
Jeez. It's like pouring liquid cooking grease down a drain. At first, it's just a film, but over time, it hardens into an impenetrable pipeline.
That's a perfect analogy.
And if you still ignore it, you hit stage 3.
Stage 3 is where the system becomes critically compromised. The continuous baking process eventually turns that tar into a hardened, shiny glaze, and it clings tenaciously to the clay flue tiles inside the chimney.
Here's where it gets really interesting, because you look at a shiny, hardened glaze, and it almost sounds like, I don't know, a protective ceramic coating, like a candy shell or something.
Yeah, candy shell. But functionally, it's pure, concentrated fuel plastered to the inside of your walls.
Oh.
All it takes is one stray ember, or a fire that burns slightly hotter than usual, to ignite that stage 3 glaze. Because it is pure concentrated hydrocarbon fuel, an internal chimney fire can instantly reach temperatures exceeding 2,000 degrees Fahrenheit.
2,000 degrees. And I'm assuming those standard clay flue tiles lining the chimney are not rated for that kind of environment.
They absolutely are not. Clay flue tiles are designed to handle the gradual warming of standard exhaust gases, so maybe a few hundred degrees. When they are subjected to a sudden explosive thermal shock of 2,000 degrees, the material physics simply fail. The inside of the tile heats up in seconds and tries to expand rapidly, while the outside of the tile, touching the cold brick, remains rigid.
Oh, man.
That differential stress shatters the ceramic instantly.
So once those tiles shatter, you've completely lost your heat shield.
Completely.
That massive heat transfers directly through the crumbling mortar we talked about earlier, right into the combustible wooden framing of the house.
That's exactly how house fires start.
But if this stage 3 glaze is hidden deep in a dark, narrow flue, how on earth is a homeowner supposed to know this transformation is happening? I mean, if I'm buying an older home, a standard inspector walking around with a clipboard and a flashlight isn't going to catch this, are they?
They won't. You can't see 50 feet up a dark, narrow shaft from the firebox. This is why the industry heavily recommends what's called a Level 2 video inspection.
A Level 2 video inspection?
Yes, especially during real estate transactions. Professionals use high-resolution camera routing, feeding a camera on a flexible rod through the entire length of the flue system.
You're literally giving the chimney an endoscopy.
It is the only reliable way to evaluate the internal anatomy of the structure. The camera will reveal hidden clay tile fractures, missing mortar joints between the tiles, or that deadly stage 3 buildup. Without it, you're basically flying blind.
Wow. So beyond the endoscopy, are there any sensory clues a homeowner can pick up on just from the living room? Like if I'm sitting on the couch, what tells me the chimney is failing?
Well, the primary indicators are drafting issues and reverse drafting odors.
Okay, odors.
Yeah. If your chimney has a heavy creosote blockage, or if a shattered clay tile has collapsed inward, the flue is physically restricted. The exhaust has nowhere to go.
So it comes back inside.
Exactly. That means smoke, or much worse, deadly, odorless carbon monoxide will draft back into your living room instead of venting safely out of the house.
And the sources specifically highlighted odors during the summer months. That felt a bit weird to me. Why would a fireplace smell worse when it's not even being used?
This goes back to the physics of air pressure and humidity.
Okay.
During a humid New England summer, the outside air is hot and incredibly dense with moisture. Your house, conversely, is likely air-conditioned and much cooler.
Right.
That heavy, hot outside air physically pushes down the chimney column. It creates negative pressure, dragging the air from the flue into your living space.
So the house is basically inhaling the chimney air.
Yes, and if that rigid sponge on the roof is saturated, rainwater is mixing with the highly acidic creosote inside the flue.
Oh, gross.
That heavy summer air pushes that wet, acidic mixture down, which is why your living room suddenly smells like a musty, wet campfire in July.
So we have ice actively fracturing the brick from the outside and a highly combustible glaze building up on the inside.
A perfect storm.
Yeah, exactly. Knowing these extreme hazards exist, I think the first impulse for a lot of handy homeowners, the DIY crowd, is to take action. They see a crumbling mortar joint, grab a ladder, head to the local hardware store for a tub of standard cement, and try to patch it themselves.
Right, which is so dangerous.
Yeah, the sources are explicit that DIY maintenance in this specific environment is a terrible idea.
It is incredibly risky, primarily because off-the-shelf materials lack the advanced chemistry required to survive the specific regional microclimates.
Yeah.
You aren't just filling a hole, you are battling complex environmental stressors.
And Maine isn't just one monolithic weather zone either. The stressors change depending on your zip code, right?
Significantly. If you look at coastal properties, towns like Biddeford or Cape Elizabeth, you aren't just dealing with freezing rain. You are dealing with galvanic corrosion.
Galvanic corrosion.
Yeah, the harsh salt air from the ocean mixes with that freezing precipitation. The sodium chloride acts as an electrolyte, heavily accelerating the oxidation of any metal components.
So the metal chase covers, the damper assemblies, even the stainless steel chimney caps are actively rusting out much faster because of the salt chemistry.
Exactly.
And what happens if you move a couple of hours inland? Are you off the hook?
Not at all. The stressor just shifts. If you move inland to, say, Augusta or Lewiston, the salt air diminishes, but you face much deeper snowpack and longer, sustained periods of deep freeze. The thermal shock on the masonry is prolonged.
But I'm still stuck on the DIY aspect. Like if I have a crack in the mortar, why can't I just buy a tube of heavy-duty outdoor sealant or standard mortar? I mean, cement is cement, isn't it?
Well, if we connect this to the bigger picture, standard cement absolutely fails in this application because it cannot survive the thermal shock gradient.
The temperature difference.
Right. Imagine the chimney operating in deep winter. The inside is rapidly heating up from a roaring fire, expanding the structure, while the outside air is 10 degrees and contracting the structure.
Oh, wow, yeah.
Standard mortar cannot handle that sheer stress. It just cracks almost immediately. Professional technicians use custom refractory mortar, specially formulated with heat-resistant aggregates to withstand those extreme temperature gradients.
Okay, what about the waterproofing then? Let's say I want to stop the rigid sponge from absorbing water. Why can't I just paint a clear, standard outdoor waterproof sealant over the bricks?
Because that is the absolute fastest way to destroy the chimney entirely.
Really?
Yes. Remember, the brick is already a sponge containing moisture, and vapor needs to escape from the inside.
Right, the breathing we talked about.
Exactly. If you seal a brick with a standard waterproof paint, you trap all the existing moisture inside the brick. When the temperature drops, that trapped water freezes, expands by 9%, and blows the entire face of the brick right off, taking your sealant with it.
Oh my God. It traps the moisture, turning the brick into a pressure cooker for ice? So what is the professional alternative then?
Professionals use a specific chemical application called siloxane waterproofing.
Siloxane. Sounds intense. How does that differ from just painting on a sealant?
It really comes down to molecular size and surface tension. A liquid water droplet from rain is massive compared to a single molecule of water vapor.
Okay.
Siloxane is a penetrant, not a surface coating. It penetrates deep into the pores of the masonry and chemically alters the surface tension of the brick walls. It makes the pores hydrophobic, meaning large liquid rain droplets just bead up and roll off.
Right.
But, and this is the crucial part because it doesn't plug the pore, those tiny microscopic water vapor molecules can still pass through and evaporate out.
It allows the chimney to exhale the vapor, essentially, without letting the liquid rain in. That is brilliant engineering.
It is very targeted chemistry. Furthermore, DIY mistakes often mask hidden dangers. If you patch the outside aesthetic but don't address a compromised flue liner inside, you are living with a false sense of security.
Yeah, that's scary.
And crucially, if a chimney fire or structural collapse does occur, and the insurance company discovers unauthorized, non-compliant DIY modifications to the venting system, it can completely invalidate your homeowner's insurance claims.
Wow, so you're not just risking the structural integrity of your house, you're risking your entire financial safety net.
Precisely.
Okay, so DIY patching is completely off the table, the stakes are incredibly high, and the weather is relentless. So what does this all mean for you? How do you strategically manage this risk without being overwhelmed by sudden, catastrophic repair bills? Let's look at the tactical playbook for homeowners.
It really comes down to understanding the curing process and timing your maintenance correctly. The most common mistake homeowners make is waiting until the first cold snap in November to call a professional.
I assume because every chimney sweep in the state is booked solid by then.
Yes, that too, but more importantly, because the weather works against you. The absolute optimal time for maintenance is between late spring and early fall. First, sweeping in the spring removes all that highly acidic stage 1 and 2 creosote so it doesn't sit inside your flue during the hot, humid summer months, actively corroding your liner.
That makes perfect sense. You don't want the acid just baking in there all summer long. But what about the masonry repairs?
That's where the curing process is vital. If you need exterior masonry repairs, tuck pointing the mortar joints, rebuilding the concrete crown at the top, or applying that siloxane waterproofing, mild temperatures are strictly required.
Okay, why is that?
Fresh mortar and advanced waterproofing compounds rely on chemical curing processes that halt completely if the temperature drops below freezing at night. Summer provides the required thermal window for restorative work to cure perfectly.
So what does this all actually mean for the homeowner's budget? Like, what does it take to professionally armor the outside of the chimney with this advanced chemistry?
Well, based on the 2026 pricing guidelines from Select Chimney Services, professional siloxane chimney waterproofing typically costs between $300 and $800.
Okay.
The final price varies depending on the overall size of the property, the steepness of the roof pitch, and the amount of surface preparation and cleaning needed before application.
$300 to $800. Honestly, in the grand scheme of home ownership, that is a relatively moderate expense.
It really is. This raises an important question about how we fundamentally value and protect our property investments. When you look at professional management, you have distinct levels of care.
Right.
Level 1 is your basic annual sweep and visual inspection. Level 2 is that in-depth video camera endoscopy we talked about. But comprehensive protection, the whole package. Sweeping, crown repair, tuck pointing, and the waterproofing we just discussed.
A full armor package.
Exactly. Spending a few $100s on professional waterproofing during a warm summer afternoon is a microscopic fraction of the financial devastation you will face in the dead of winter if you ignore the rigid sponge.
No kidding.
We are talking about the staggering expense and massive logistical stress of a collapsed structural masonry rebuild, or the thousands of dollars required for mold remediation in your attic because water penetrated the porous bricks, bypassed the flashing, and destroyed your insulation.
It's the ultimate ounce of prevention versus a pound of cure. You are basically trading a moderate summer appointment for absolute peace of mind when the blizzard hits in January.
Yes, you are preserving the architectural integrity of the entire home envelope, not just cleaning an exhaust pipe.
That is a wild journey to think about. We started by looking at this seemingly invincible brick monolith attached to the house and realized it's actually a highly fragile, rigid sponge.
It really is.
It absorbs water, expands by 9% when frozen, and systematically tears itself apart from the roof down. And simultaneously, it's hiding a potential 2,000-degree, highly combustible glaze in the flue, just waiting for the right thermal shock to shatter the clay tiles.
That's a lot going on.
It's a perfect reminder that a home's most solid-looking features often require the most proactive, specialized care.
They require deep understanding, not just surface-level assumptions. And if I can leave you with one final provocative thought to mull over, it's this.
Let's hear it.
Consider the chimney not just as a structural exhaust pipe, but as the primary lung of your home's entire ecosystem.
A lung?
It is the core of your home's thermal and respiratory regulation. If moisture infiltration and internal creosote blockages are silently choking off this lung, well, how does that restricted airflow and trapped humidity systematically alter the air pressure, the indoor air quality, and even the structural foundation of the very rooms you sleep in every night?
Man, that is something you definitely want to figure out before the snow starts falling. Thanks for taking this deep dive with us. We'll catch you on the next one.